Good morning, students. Today we are going to start a new topic in the subject of chemistry, that is the particulate nature of the matter. So concentrate yourself. This is a topic in the subject of chemistry O levels. So this is an important topic. Concentrate yourself. Here we are going to start. Here is a question, and the statement is: a crystal of the purple compound potassium manganate is placed at the bottom of a beaker of water, and the beaker is left until there is no further change. What will be observed? And the options are here. Number one, a uniformly purple solution. Second, a colorless liquid with the purple crystal unchanged. Number three, a purple layer below a colorless layer. Number four, a colorless layer below a purple layer. And last one, a deep purple layer below a pale purple layer. And the answer will be A part. Diffusion has occurred. The potassium manganate crystal dissolves in water to form colorless potassium ions and purple manganate ions. So these manganate ions will be responsible for the purple color throughout the liquid that collide continuously and randomly with water molecules and with each other also. The purple manganate ions diffuse from a region of the higher concentration at the bottom of the beaker to a region of the lower concentration, the rest of the water in the beaker, until they are uniformly distributed throughout the whole solution. So this will be happened in this question. Here is another question. The apparatus below is used to show the diffusion of the gases. Which pair of the gases X and Y would cause no movement of the water? So you can see here is the water and here is the gas Y that will come from the environment. You can see the direction of the arrow, and here is the gas X in the porous pot. So gas X will go out and gas Y will come in. So the question is, which pair of the gases X and Y would cause no movement of the water? And here are the options. A part is carbon monoxide and nitrogen dioxide. B part is CO2 and C2H6. C part is C2H4 and C2H6. D part is NO and C2H4. And E part is N2 and C2H4. Because the statement is which pair of the gases X and Y would cause no movement of the water. So if there is no movement of the water, it means the density of the gases, or in other words, the relative molecular masses of the gases will be equal. So the diffusion of coming out of the gas will be equal to diffusion of the coming in of the gas will be equal. So relative atomic masses should be equal. So then there will be no movement of the water. This is the answer. Since there is no movement of the water level, the rate of the diffusion of the gas X out of the small beaker through the porous pot should be equal to the rate of the gas Y diffusing into the small beaker. Gas X and Y must have the same density and therefore the same relative molecular mass. So in all 5 parts, first we will find the relative molecular masses of both gases into the column. For example, in A part there are 2 gases given, so we will find the relative molecular mass of the 2 gases in the A part. Likewise, B, C, D and E part will be done, and the part in which the relative molecular masses of the gases will be equal. So that will be the answer. So look now, gas X and Y must have the same density and therefore the same relative molecular mass. Both N2 and C2H4 have the relative molecular mass of 28. So that's why E part is the answer. Here is the next question. The percentage of the oxygen in the air is found using the apparatus shown in the diagram below. So this is the apparatus used for finding the percentage of the oxygen in the air. The air is passed over the heated copper wire. So here is the copper wire and the wire is heated through a Bunsen burner until there is no further decrease in the volume. What precaution should be taken before the initial volume of the air and final volume of the gases remaining in the apparatus are found? And the options are: A part is the tube containing the copper should be removed. Okay. Second is the apparatus should be at room temperature. C part is the air should be dried. D part is both syringes should contain the same volume of the air at the start. And E part is all the copper should have reacted. B part, the apparatus should be at room temperature, will be the answer. And look now, here is the explanation. The volume of the gases expand when temperature is increased and contract when temperature is decreased. An accurate change in the volume of the air is measured when the initial temperature of the apparatus containing the air is at the same as the final temperature. So the temperature should be same before and after the reaction. Thus, the apparatus must be cooled to room temperature again before taking the final volume of the air. So the precaution in the experiment should be the apparatus should be at the room temperature. Here is another question. Which of the following gases is least common in air? And the options are: A part argon, B part carbon dioxide, C part hydrogen, D part nitrogen, and E part oxygen. And the answer is C part, that is hydrogen. And here is the explanation. The composition of the dry air is 20%, almost 20% by volume of the oxygen, 78% by volume of the nitrogen, 0.03% by volume of the carbon dioxide, and approximately 1% by volume of the rare gases, that is mainly argon. So C part is the answer, that the least found in volume in the air is hydrogen gas. And other question is here. An experiment was set up as shown below. After several days, the liquid in the jar had the same blue color throughout. This was the result of the movement of, and you can see in the jar, the upper portion is containing the distilled water and the lower portion is containing the aqueous copper sulfate. Actually, these are two beakers. One beaker is containing the distilled water and the second one is containing the aqueous copper sulfate. And the beaker containing the distilled water is inverted over the beaker containing the aqueous copper sulfate. So now this statement is: after several days, the liquid in the jar had the same blue color throughout. This was the result of the movement of, and here are the options. First is sulfate ions only. So the given is, this is the result of the movement of the sulfate ions only. Second is, this is the movement of the copper ions, sulfate ions, and the water molecules only. C part is, this is the result of the movement of the copper atoms and sulfate molecules. D option is, this is the result of the movement of the copper sulfate molecules only. And the last option is, this is the result of the movement of the water molecules only. And the answer will be B, because the apparatus is containing, the lower beaker is containing the copper sulfate and the upper beaker is containing the distilled water. So the uniform purple color will be because of the all three molecules, that is copper ions, sulfate ions, and the water molecules. So this is the answer, B part. So look now, here is the explanation. The uniform blue solution is a result of the diffusion. The copper ions and the sulfate ions collide continuously and randomly between themselves and with the water molecules. And because of this, diffusion will occur, and after several days, throughout a blue color will be occurred in the jar. Here is another question. This statement is, which statement explains why the compounds propane, that is C3H8, and carbon dioxide, that is CO2, diffuse at the same rate at room temperature and pressure? So remember one thing, that is the key point for this kind of the question. for diffusing at the same rate, the gases should have the same density and their relative molecular mass should be equal. So these options are: A part, they are both gases; B part, their molecules contain carbon; C part, they have the same relative molecular mass; D part, both have denser than air; and E part, both molecules contain the covalent bonds. So the answer will be C part. They have the same relative molecular mass. So look now, C part is the answer. They have the same relative molecular mass. And here is the explanation. In order to diffuse at the same rate, both gases must have the same density and hence relative molecular mass should be equal, because if the relative molecular mass will be equal, they will have the same density. Both propane and carbon dioxide have relative molecular mass of 44. Here is the next question. Three dry test tubes were filled with different gases and placed in a trough of the water. You can see here, this is tube 1, this is tube 2, and this is tube 3, that is filled with different gases and are inverted in a trough of the water. After a short time, the water had risen in two of the tube as shown in the diagram. You can see the tube 1 is fully filled with water and tube 3 is almost half filled with water and tube 2 is empty. No water has risen into the tube. The statement is which gases could be the tubes have contained. And here are the options. In tube 1, that is ammonia; tube 2, carbon dioxide; and tube 3, hydrogen. So you can see in all the options, three gases are there. One is ammonia, second is carbon dioxide, and third one is the hydrogen. So we have to understand which gas is more soluble in water and which is less soluble and which is least soluble. So remember one thing, ammonia is the most soluble gas in the water. Then comes the carbon dioxide gas, that is less soluble in water, and hydrogen is least soluble in water. So here you can see now, in tube 1, the water has risen to almost top of the tube, so it must be the ammonia gas. In tube 3, you can see water has risen up to half of the tube, so it must be carbon dioxide. And tube 2 is empty, so it must be hydrogen. So 1 is ammonia, 2 is hydrogen, and 3 is carbon dioxide. So it must be B answer: ammonia, hydrogen, and carbon dioxide. So B is the answer, and here is the explanation. Of the three gases, ammonia is the most soluble gas and therefore it dissolves most readily in the water. Carbon dioxide is less soluble in water and hydrogen is the least soluble. Here is another question. This statement is: in a sample of the air at 25 degrees C, the molecules of the oxygen, nitrogen, and carbon dioxide are all move with different average speeds. Which of the following lists the molecules in order of decreasing average speed, that is from fastest to slowest? So the key point in this question is, because only three molecules are given, that is oxygen, nitrogen, and carbon dioxide. So first we will find the relative molecular mass, and the molecule with the minimum, with the least relative molecular mass will move with the greatest speed, and the molecule with the greatest relative molecular mass will move with the least speed. So this is the key point. So first we will find the relative molecular mass and then we will decide. Anyways, here are the options. A part is carbon dioxide, then oxygen, then nitrogen. B part is nitrogen, then carbon dioxide, then oxygen. C part is nitrogen, then oxygen, then carbon dioxide. D part is oxygen, then carbon dioxide, then nitrogen. E part is oxygen, then nitrogen, then carbon dioxide. And the answer is C part. And here is the explanation. the higher the relative molecular mass of a gas, the denser the gas and lower the average speed of the diffusion. So first we will calculate the relative molecular mass of the gases and rank them in order of the lowest relative molecular mass to the highest, because the order we have to arrange is from the fastest to the slowest. So fastest will be with the least molecular mass and slowest will be with greatest relative molecular mass. So look now, in choice of C, relative molecular mass of the nitrogen is 28, relative molecular mass of oxygen is 32, and relative molecular mass of carbon dioxide is 44. So this is the least relative molecular mass, so this will be the fastest, then this will come, and finally this will be the least fastest. Here is another question. The statement of the question is, which statement provides the best evidence that matter may exist as the tiny particles moving at random? And the options are: A, many elements conduct electricity; B, air can be readily compressed; C, a small mass of the water produces a much larger volume of the steam; D, if a bottle of the ether is opened, the smell is quickly detected in all parts of the room; and E, a thin layer is formed when an oil drop is placed on the water. So actually the key point in this question is diffusion is the evidence which actually best evidence that matter may exist as the tiny particles moving at random. So the answer must be D part. If a bottle of the ether is opened, the smell is quickly detected in all parts of the room. And the answer is D part. So look now, and the explanation is here. Ether is a volatile liquid that evaporates rapidly. The gaseous ether molecules collide rapidly between themselves and with the gas molecules in the air and diffuses rapidly throughout the room. Here is another question. The diagram shows the apparatus used to investigate the diffusion of the gases. And here is the apparatus. You can see gas at room temperature and pressure in this compartment. Here is the porous barrier and here is the vacuum. And the requirement is which gas would diffuse into the vacuum at the slowest rate. And the relative atomic masses are given: H1, C12, N14, O16, and S32. And here are the options. A is ammonia, B is carbon dioxide, C is hydrogen, D is nitrogen, E is sulfur dioxide. So the requirement is which gas would diffuse into the vacuum at the slowest rate. And the key point in this question will be, first we will find the relative molecular masses of all the gases in the option, and the gas with the greatest relative molecular mass will move with the slowest speed. And the answer is E part, that is sulfur dioxide, because after finding the relative molecular masses of all 5 gases, we will come to the point that the sulfur dioxide is having the greatest relative molecular mass, so that's why it will move with the slowest rate. And here is the explanation. The gas that diffuses at the slowest rate has the highest relative molecular mass. The relative molecular mass of SO2 is 64. So E part is the answer. And other question is here. The diagrams shows the spacing of the molecules in the 3 states of matter. You can see this is diagram 1, this is 2, and this is 3. Which state does each diagram show? And if you are given the 3 options, solid, liquid, and gases, so definitely this is the solid, this is the liquid, and this is the gas. And here are the options in A part. This is gas, liquid, and solid. So in B part, first one is gas, then 2 solid, then 3 liquid. C part is in first liquid, second gas, third is solid. D part is in first liquid, second solid, and third is gas, and E part is first solid, second liquid, and third is gas. So the answer should be C part, because third one, a container should be solid, first one liquid, and second one was gas. And here is the explanation. C part is the answer. The particles in a solid are packed closely together and arranged in a regular lattice. Their particles can only vibrate in fixed positions as there are strong forces of the attraction between the particles. In a liquid, the particles are further apart and can move slowly past each other as there are weaker forces of the attraction between them. The gas particles are far apart and move randomly at high speed. Another question is here, which gas is used for filling the light bulbs? And here are the options. A part is argon, B part is carbon dioxide, C part is chlorine, D part is hydrogen, and E part is oxygen. So the key point for this question is argon gas is used for filling the light bulbs. And here is the answer, that is A part. And here is the explanation. Argon is a rare inert gas. Being very unreactive, it does not react with the hot tungsten filament. If the light bulb is filled with oxygen, the tungsten filament burns up at high temperature to form the oxide that causes blackening of the light bulb. Here is another question. The diagram represents a closed vessel containing equal volumes of the water and steam at the 100 degrees C and atmospheric pressure. So you can see here is water and here is steam. So containing the equal volume. So this volume is equal to this volume. Requirement is which of the following statement is correct? And the options are A part. Equal number of the molecules are present in the steam and in the water. B part is the only type of the movement possible for the molecules in the water is vibration. C part, some of the molecules in the steam split into hydrogen and oxygen molecules. D, molecules can move from the water into the steam and from the steam into the water. And E part, the average kinetic energy of the molecules in the water is greater than that of the molecules in the steam. Answer must be D part. Molecules can move from the water into the steam and from the steam into the water if the volume remains same. So it means the rate at which the water boils into the steam should be equal to the rate at which the steam condenses into the water. So the both rates will be equal. The rate at which the water boils into the steam should be equal to the rate at which the steam condenses back into the water. So D should be the answer. So D part is the answer, and here is the explanation. A dynamic equilibrium is attained in the closed system at the specified conditions. The rate at which the water boils to form steam is equal to the rate at which the steam condenses back to form water. Here is another question. Which statement about the behavior of the particles in a gas is not correct? And here are the options. A part is they spread throughout the vessel in which they are contained. So this is true about the gas. B part, they are able to move at high speed. This is also true for the gases. C part is they are arranged in a regular pattern. This is not correct because this is correct for solids. D option is there are large spaces between the particles. So this is also true for the behavior of the particles in a gas. And E option is their collisions with the walls of the vessel cause pressure. So this is also true for the behavior of the gas. So C part is not true. So C must be the answer. So C part is the answer, and here is the explanation. Particles in a gas possesses more kinetic energy and are always in continuous random motion at high speeds, colliding with themselves and the walls of the container. So the C part is the answer. So C is the option which is not correct about the behavior of the gas, that they are arranged in a regular pattern. So C is the answer. So this was the lecture, students. So read it again, understand it, learn it, and make your notes. Thank you so much.